Hi everyone, today I will be presenting my design proposals and the direction I intended to pursue, as well as the potential specific industry sector that I have investigated in relation to making samples. My research revolves around the concept of integrating slide mold and spirulina into the design process of the wearable textile, exploring their potential through a range of the interdependency between the human and non-human elements. The slide mold is a yellow organism that can generate an effective network while searching for food, and I aim to utilize its autonomous pattern generation capabilities as a participant in the design process. On the other hand, the spirulina, which is a highly nutritional edible microalgae, holds the great potential as an eco-friendly material. To begin, I was interested in the hand-free embroidery technique with the soluble fabric. As we can see in the video, the pattern used in this sample are special networks generated by my slide mold simulator, and the embroidered samples possess the special texture and hollow-out shape that interact with light and shadow. Although the samples are just flat pieces, I think it has the potential to develop the design of a 3D shape with this technique. To involve the algae in my practice, I have found an embroidery thread called alginate fiber, which is 100% biodegradable threads made from algae and cellulose. The alginate is a natural polymer that exists widely in many species of the seaweed. And I have ordered some the alginate fiber as I would like to use this material in combination with the embroidery techniques in my future development. Furthermore, I have made a lot of the biomaterials related to the spirulina, both the spirulina powder and the living spirulina culture. For detailed recipes, please refer to the process record in my Padlet. It is important to note that the living microalgae do not survive temperatures above the 30 degrees Celsius. Therefore, the mixture heating process can result in killing those living microalgae. However, my experiments have shown that adding the sugar to the recipe can help retain the green color of the microalgae. As the picture shows, the microalgae in the sample without added sugar have turned yellow. And the 3D printing is the major investigation of my practice. These two samples are 3D printed one-piece locking structure, which allows the sample to bend and wrap around the item. This structure holds the potential for further development as a bag or the wearable accessory. In my projects, the slide molds serve as a visual guides. By programming them in the software, I can simulate their growth path in a 3D space and convert them into the 3D models. And I have created a specific organic pattern based on the path of the slide mold generation. In this sample, the organza was added midway through the printing process, and I cut out the pattern individually. I think there is a potential for those small patterns to be made into the textile by patchwork or embroidery in my further exploration. Moreover, I also tried to generate a 3D model attached to the body. The 3D printed sample were 1:1 in size, which fitted my arm perfectly, and this sample could be further developed into a piece of the jewelry or a part of the wearable device. Furthermore, based on the 3D printed form, I could cast the shape with other material, or I can create the texture by using the embroidery. During the week 4 lecture, I found an inspiration from the algae curtain by Loop PH Studio. It is the potential to incorporate spirulina through a tube. Spirulina has excellent CO2 absorption properties, and I believe it could serve as a functional wearable CO2 capture device. Initially, I tried to crochet the tube in my sample, but it didn't work well as a bending out of the silicone tube would cause the flow to be blocked. And I have tried 3 different thickness and 3 different materials of the tube at this point. The medical capillary tube is the best performer. This is a very thin tube with inner diameter of 1.5 millimeters. By employing the macrame to weave the tube and using the 3D printed accessory as the endpoints, I successfully hold the tube in place, while the syringe was utilized as a tool to drive the liquid flow. This video shows the effect of the spirulina flow through the tube. During the testing, the spirulina flows smoothly through the tube and dripping drop by drop as the output. In the future iteration, I plan to investigate how this sample can be fused with the body as the wearable design, establishing a sustainable life cycle by harvesting the spirulina as the food source. Moving forward, during the week 7 to 10, I will continue to develop the design in the wearable sector based on my current sample, and I think that the interaction of the human body with the object is an important part of exploring the symbiotic relationship between human and non-humans. It is possible to combine the 3D printing of slime mold model and weaving of the tube with spirulina culture to design the wearable CO2 captures. Additionally, I will explore the embroidery with the alginate fiber to form the 3D shape based on the slime molds generated. Overall, the smart textile is an interdisciplinary and a hybrid technology designs, and I have learned a lot from this course. I'm looking forward to my assessment to outcome. Thank you.